So then our next topic is going to be multicast nonstop forwarding, right? And we'll do the same thing here, take care of the presentation, and then Daryl will run through the demonstration again and show the actual feature in live in action, right? So similar agenda, the overview, just a high level first, and we'll take a look at some of the use cases and then jump in a little bit on the details and caveats, things to kind of watch out for, configuration, best practice, troubleshooting. Yeah, so let's go ahead. Now, with the overview of multicast nonstop PIM nonstop forwarding, the idea is to basically support or ensure lossless failover for multicast traffic. Now, here we have on the right side, for example, even though it's a standalone, matter of fact, this feature it's a local on the device, right? So even a standalone switch definitely will benefit from this, because let's just say when this feature is in an active state, right? When we program the multicast routes in the hardware, and when this feature is in an active state, we do not remove these multicast routes from the table, right? And we use that route entries that was programmed to continue forwarding of the multicast stream across, while the PIM module will reconstruct its internal cache, and the users will not see any disruption to the existing stream, right? So then there are basically, in what type of events? A being, of course, when your PIM module, the daemon, restarts. So in a live production, if I restart the PIM module, it shouldn't affect the multicast stream that is basically going across from multicast source to core 1 and to switch 2 and across to the access switch to our receiver, right? While the process of the multicast PIM module is being basically restarting, right? Or we'll take a look at some of the redundancy for if I have basically redundant management modules, right? How we handle that. They're all pretty much handled in the same manner, right? As far as when the PIM nonstop forwarding mode is inactive, the module, basically PIM module triggers a restart timer, and then the internally basically starts rebuilding the protocol stack. And so we'll take a look at the VSF, and then ISSU operations as well. Supported platforms, 6200 series, 6300 series, 6400 series, both the 6405, 6410s, 8320s, 8325s, 8360, the 8400s, and the 10,000. Use case. So we talked about, first thing first, we said it is a, if I had a standalone switch, sure, right? That was basically when the module of the daemon restarts, right? But what happens when I have a redundancy? So looking at 6400 series, for example, maybe 6405s or 10, whichever, or the 8400 series, because we have the management module, right? We have redundant management module. In that scenario, so a switch with dual management module multicast traffic continues to flow if the active management module fails, right? Because the switch database is synchronized and multicast routes were programmed in the hardware now, and then the M routes are not removed during these events, and that event being basically our management module failure, right? So, but in the meanwhile, the PIM module on the newly active management module will reconstruct its internal cache while there's no the user doesn't see any kind of disruption across, right? So this being, of course, if you have your redundant redundant management modules. I do want to point actually one other thing in here. When we have our let's just say, for example, with our PIM module daemon restart or redundancy, right? So, but actually, I'm going to hold that off, and when we get to the VSX, yeah, that would make better sense. PIM module switchover, VSF, same, right? Again, this feature we said it isn't. I didn't mention that, but it is enabled by default, and it is local on the device. So with the VSF, our virtual switch framework. So in this case, we have the conductor being the primary that handles basically the control and the management plane operations, while the data plane of all of our switches are in operational. And then we have elected here our standby conductor, right? Now, it is basically the conductor will basically synchronize, right? Using the, of course, synchronize the database of our standby conductor, right? Using OVS DB, right? We synchronize across, and then also programming of the hardware with our multicast routes. And in this case, if our conductor failure happens, well, chassis switch over when VSF conductor fails. And since everything was already synchronized, but yet the data plane is not affected, so our receiver will continue receive the multicast stream from a source in this operations. And then with our PIM module switchover, right, being in our ISSU, when a user triggers a in-service software upgrade. Now, so in this case, for example, when we are in a process of in-service software upgrade, so switch over are similar to daemon restart. Again, there's no messages that are being exchanged between these VSX node regards to PIM nonstop forwarding. They are locally being handled on each device. PIM nonstop forwarding is local to the device. It does not exchange any information, right? Whenever we trigger this ISSU, the PIM nonstop forwarding operation gets triggered as well. And in the same process, right, the PIM will construct the other, if we have started a reboot process on our secondary, right? So then the process when the secondary is back online, well, the primary is still routing the data. And then also in that case, basically, when the secondary is back online, it will construct its internal cache from its neighbors. Also, please note, when it comes down to PIM nonstop forwarding will not be activated if the PIM daemon crashes during VSX graceful shutdown process. So all those entries are clear and relearned in this case, right? When the PIM daemon starts, here's the key thing, that when the PIM daemon starts, a check is made basically to see if the VSX switch update or upgrade is in process by checking the control plane shutdown in initiated state. And if the device is in the process of the upgrade, then the nonstop forwarding is not activated. So this is something to keep in mind, because it does check. If it's in the process, then it will not activate. When the PIM nonstop forwarding state is an active state, there is a timer that basically we have that 210 seconds, right? And we maintain and continue forwarding the multicast traffic across without adding or deleting of any M routes into the tables. Details and caveats. So in a PIM nonstop forwarding mode is active again by the events, as we said, the module, PIM module, or the daemon restart, the redundancy, and a 6400 series or 8400 the management modules, or with our stacking, the VSF, or with our in-service software upgrade, right? So in this state, when the PIM nonstop forwarding mode is active, the module triggers a restart timer, which is 210 seconds, right? The default. Currently, that timer you cannot modify, but in future, they will allow to modify that timer, and internally starts rebuilding the protocol stack, right? States, I should say. When the restart timer, so what really happens, this is the key point here, right? When we are in an active mode, existing M routes are not impacted because there's already been programmed in the hardware, and the traffic flow is not interrupted. It's the key takeaway, at least from here, right? Since we are in an active state, well, we cannot add any new M routes, right? Because the PIM module, the daemon, is in the process of restart. Well, we cannot add or delete anything as far as M routes into the tables, databases. But if any flows that is newly arrive in any of these interfaces during this time, that will be updated to the DB installed in the hardware immediately. If there is any future update, such as outgoing interface list updated or deleted, then a newly arrived stream would take place immediately. We're talking about the stream versus MRoute here, right? The routing tables are built, and we cannot add or delete because that daemon is in the process of restart. But since we have already programmed what is already in the hardware, we can use those and to forward the multicast stream. And that's the whole point, right? To have uninterrupted multicast traffic go across based on what has been programmed in the hardware. All right, so then here, then any inactive MRoute entries get timed out, will be removed from the MRoute table once the restart timer expires, which is 210 seconds by default. Now, when the timer expires, what happens? There's two operational modes, if you may. There's a mark operational and sweep operational. And a mark operational, new entries, basically. The new entries that was present in the PIM protocol cache are going to be inserted in the database. So our M routes. And then sweep operation, well, the stale entries will be removed from the database, right? Those are the two things. And from there on, once that is completed, the normal processing of MRoute is resumed. Now, here we are, a few things to kind of keep in mind. Since this feature is enabled by default, right? Very important to keep in mind with show IP PIM, and it's enabled. And then by default, and you can disable it, at least in this current codes. All right, and then the next, the inactive is saying it's enabled, but it's an inactive state. But when you do show, when it's an active state, you can see the active, right? The nonstop forwarding state is active, and the timer. Notice in here you didn't see timer. Now that is active, then you have this timer coming into play, and that's showing basically the active timer that we spoke about, 210 seconds. And again, remember, in future code, it may be available to us to make it, they want to make it configurable. All right, then PIM nonstop forwarding support. Here we are with sparse mode, source-specific multicast, and dense mode protocols, and then support for both IPv4 and IPv6. Now, some of the caveats we should kind of consider and think about, keep in back of our mind. With regards to sparse mode, the solution only works on non-RP devices and non-source connected DR routers. So, but it is supported on all other routers, like your last hop, intermediate routers, and the BSR router, right? If there's a PIM module crash, during the graceful shutdown process, multicast traffic outage is expected. As we said in a earlier, that when this module crashes on us, then especially in a VSX environment, the system comes up and sees, basically looks first thing first, for example, if the system is in a progress of upgrade, right? And that being basically that it looks for that control plane shutdown initiated, right? And when that state is there, then it will be in an inactive state. It cannot go in an active state because we're in the process of upgrade. That was just one example of it, right? When it comes back. Update to existing neighbors, BSRs and RP set information, including timers, are not published, right? Again, because everything in that case, it was basically programmed in the hardware, and this, the module, the daemon, is in the process of restart. While in a non-stop forwarding mode is active, right, during that timer, which we set 210 seconds, modification to existing en route is not allowed, right? And if you get leave messages, right, because IGMP, for example, when a host leaves the multicast group, it sends a leave message, for example. Well, yeah, it will not be processed and traffic will continue to flow. Sure, right? And this is to ensure that any existing traffic flow is unaffected during the restart timer. All right. Configuration, well, there's not much to the configuration here because it is enabled by default and you don't have an option to disable it, right? But we can use some of our previous commands, show IPM routes and show IP PIM, as we saw, only when you are in you can see that you're in an inactive state or active state. And there's the events we can look for, basically PIM daemon message in here. When that process kicks in, it will tell you you are in an inactive or active state. Well, there's no best practices. This is enabled by default, and that's that for this guy. So let's take a look at the troubleshooting. Similar kind of troubleshooting systematic approach as far as the physical topology and the physical cabling and so on being checked. Some of the show commands, we'll take a look at it from here, right? So we have our topology, right? And then verify your PIM neighbors are up and operational and the multicast routing is correct between the multicast source and receiver. Very important, right? Always we have to make sure the multicast tables are, M routes are correctly populated. And verify the data plane, right? With PIM nonstop forwarding status, active or inactive with your show IP PIM, right? And then check to see if the M routes is still intact and forwarding, right? The routes. In the state, we will see its route basically. And check the event logs for your PIM daemon nonstop forwarding. We'll take a look at that. And you can always, and if you had even in such an environment, you can, if you wanted to test things out, right? You can go in a shell command and basically trigger this nonstop forwarding, right? And to see, while you can reboot, basically restart the PIM module, and yet your multicast stream will be uninterrupted. And we're going to see that as Daryl demonstrates that for us. So show IP PIM neighbor, we, again, the same commands that we spoke about. We see the PIM neighbors, the M routes, the multicast, the source, and then the incoming interface, the outgoing interfaces, right? Important. And then show IP PIM, we saw this earlier, but here we are part of the verification and troubleshooting, right? So we do see it's inactive. And if you are in an active state, you're gonna see that the nonstop forwarding state is active and the timer, 210 seconds. Show IPM routes. So we do see the state is routed, right? So this is basically what we're using forwarding multicast streams. Show events. And then, of course, for the calling for a specific PIM daemon, right, include NSF, right? And in here, we can see in the events that NSF timer activated. And when the timer is complete, resume no more operation. So there are some log messages you can see. You can call for that in the events when events are occurring. Oh, and of course, lastly, can we trigger, and for our testing purposes, we can force, right, and restart the PIM module. So first thing first, we see that it is inactive, right? The nonstop forwarding. By going into the shell, right? Start shell and sudo bash system CTL restart pim, right? And then exit out, and we can see here we are. That of course you want to have your multicast stream running so you can actually see that there's no interruption in your multicast, and you can verify that, okay, the state is active and so on, and yet your multicast stream is operational still uninterrupted. All right, Daryl, to you then for demonstration.
Okay.
I'm gonna stop sharing.
Okay. So this is the Multicast NSF demo topology. I have a source on the left, the streaming of video to 239.1.1. I have switch 1, switch 2, that is actually on 10.10. Switch 3 is on 10.9. I have a receiver here, 30.1.1.21. What I'm going to do is show you multicast forwarding is impacted by control plane restart on 10.9 switch. Show you the before and show you after with 10.10. It's not impacted when I do a control plane restart. So let's take a look at the receiver, 30.1.1.21. Here, 30.1.1.21, and it's receiving the stream correctly. Let's look at switch 3, try PM route. You can see it's actually incoming and forwarding out VLAN 30 towards this receiver. Same for switch 2. It's streaming correctly. What I'm going to do next is do a control plane restart on the 10.9 box switch. Here, I'm going to do a control plane restart. You can see the video stop. So with that, I'll do this command, systemctl restart pim. The video should stop after a while. And it stopped. Okay. You can see multicast forwarding has stopped as well. It takes some time for it to recover. Switch 2, you see it. It's not being forwarded. What can we check? We can also check while waiting. PIM. There was no NSF information in 10.9. It's 10.9. 10.10. You can see this new field. NSF status. If you compare. Right? So this is new. So inactive is what we want to see normally. Everything's working. You can see now the stream is finally back. So multicast stream. Now forwarding out. Like I said, inactive is the normal. There's no problems, you show inactive. If there's a problem, it will change to active. So let me do that again. We start the control plane. Shouldn't see any impact to the video. It's flowing. You can see now NSF is active. It has kicked in, timer is counting down. But forwarding is still running as expected. Here and here. Forwarding is still running. Right? So the video is still working. So just by upgrading 10.10, customers will get the benefit of PIM NSF. There's no additional configuration required. And this feature is applicable to both IPv4 and IPv6 multicast. With that, thanks